Hey guys, it's Beej from Complete Developer Podcast. Um, Here doing my homework again. If you're just tuning in for the first time, uh, what these videos are, my professor in grad school is requiring that I do YouTube videos and submit those for my homework. Each week we have 4 problems that we have to solve. I do the code and then I walk through it and show that it's running on here. If you're not a fan of the podcast, definitely check me out each week on Complete Developer Podcast, where my best friend and mentor and I talk about everything from what it's like to be a developer to serious technical things to things like life and getting better sleep, organizing your schedule, all sorts of stuff. All about being a better software developer and being a better human being. So let's go ahead and jump on into the homework this week. So my first problem was to display an integer reversed. Basically, I had to write a method that took an integer and displayed the reverse of it. So here's my method declaration. Go down here. I'm taking in the input from the user, calling my method. Method basically loops through and while the number is greater than 0, it outputs the number mod 10, or basically the last digit in the number, and then divides it by 10. So let's see how this works. I'm going to be kind of boring here and just do 1, 2, 3, 4, 6. 6, 4, 3, 2, 1. Works pretty well. Alright, hopping on over to our next one. Let's set this as our startup project. So this one is called twin primes. These are basically a pair of prime numbers that only differ by 2. For example, 3 and 5. If you can read my screen, you can see exactly what I'm reading from. What this assignment asked me to do is to go through and create a list of all the prime pairs or the twin primes less than 1,000. So here we are declaring our variables. Since there's not a user input, it's just sort of weird throwing that up there. So I put a little title here. Then we just loop through from 0 to 1,000. Go through a set an is prime equals true, and then we just compare. We'll say, all right, from 2 up to 1 less than the number, if it's divisible by any of those, then it's not prime. And so then it goes down. If it is prime, then it looks and says, all right, is this number 2 more than the previous number? Then if it is, it outputs those 2. If not, it puts that into the previous prime, stores that for the next iteration. So let's go ahead and run this. Alright, so as you can see, we've got our prime pairs, or twin primes, going all the way down from 3 to 883. Pretty straightforward, that one. It was kind of easy and quick to write. I enjoyed it. Alright. Next one. Weekly hours. Basically, computing the number of hours per week for an employee, actually a set of employees. So up here we have our declared variables. I have a 2D array of hours, a 1D array of employee names. Then I created this constant array of weekdays. That's so that I can iterate through 1 through 7 and just pop up how many hours on this day. And you'll see that in just a moment. Then over here we ask our user to enter the number of employees. From that we build our arrays, and then we get the employee's name and their hours. And then we go back and get the next employee's name and their hours. Once we've gotten all that input, we come down here, we calculate the total hours, and we output that per employee. So let's see how this works. All right, we're we're going to do 2 employees so I can show you that it works with more than one. First one, we'll do me, BJ. Hours on Sunday. I do not work on Sundays. Monday, 7.5, 8-hour day with a 30-minute lunch break. Same for Tuesday, Wednesday, Thursday, and Friday, and then on Saturdays I am off. Second employee's name, do my girlfriend. She does not work on Sundays. Mondays, she works about 4 hours. Same on Tuesdays. Some Wednesdays she works, some she doesn't. We're going to say she's working this Wednesday. Thursdays, she tends to work, it's about 8 hours on Thursday. Fridays about 12 hours. She works a long day on Friday. Saturdays about 10 hours. So here you have our totals. 37.5 for me, which is correct, and 42 hours for Amanda. Pretty straightforward. All right. This next one is the fun one. I really enjoyed this. This was a bit of a challenge, but it was still a lot of fun to build. Oh, hey. I forgot to remove that. So I need to take that out of the Word document I'm submitting as well of all my code. But yeah, I had a couple of different ideas I played around with, did some refactoring on this one and forgot to remove that declaration for the method there. So basically this is creating a tic-tac-toe board. Amanda was here and helped me test it. Unfortunately, she's at work right now, and I would wait until she got off work and came over to visit to go through this, but I'm going to be getting a tattoo in a few minutes as soon as I get done recording this, and so it might be pretty late when I get back because we're going to go out afterwards and hang out. So yeah, I didn't want to push the limit on how late we could stay out and have to come back and get this submitted. So she's not here. It's just going to be me playing against myself. All right, so here we go. Created a global variable for the board array. That way I don't have to pass it back and forth, and it's just easier to work with. Then our methods are declared here. Declaring variables. Then I instantiate a blank board, and you'll see that in the display. One of the things was we had to redisplay the board every time. I'll show you that on our display board method so that it calls the display board. What that does is, first thing it does is it clears the screen, so we get a fresh board every time. Then it does our column names, A, B, C, and then iterates through the first loop, and that gives us our row numbers, and then it posts what's on the board. So our initial one will just be blanks, and that's a character array, so it's pretty straightforward. You're not going to get a lot of extra in there. We come down here and we loop through while we don't have a winner or the board is not full. Now I realize that we can think ahead and see that a game is going to be a draw before the board is full, but that was not part of the requirements for this assignment, so I did not build that in. I focused on the requirements. I added one little extra feature just because it got annoying when I typed the wrong thing. And that comes up next, where we get our player information. So basically it sets the player based on the iteration. So X starts, and so if it is divisible by 2 or an even number, you are X, odd numbers are O. Tells you whose turn it is and asks you to enter the number for play. The interesting thing I ran into with this was if X chose the A1 box and then O chose the A1 box, it would overwrite it. So that's why I created this loop check for the error check loop that basically says, hey, if it's not an empty spot, that's an invalid selection. Try again. And it'll just keep doing that until you put in a valid selection. And then because it's only going to loop through it as many times as there are selections on the board, you're not going to have a point where you can't make a valid selection. There will always be that option. So then it sets the player on the board, checks for a winner. That's down here. And I'll talk about this in just a moment. So we check our horizontal by iterating through the columns. We check our vertical by iterating through the rows. And then we check our diagonals. I was going to do something fancy here, and I realized that because it is a 3x3 board, that it would just be easier to create a series of if statements than to try and do something fancy. So I went the more human readable route and did this. It's pretty straightforward. If it's in position 1, 1, then we look at, which would be the very center of the board, because it's always going to pass through the center. So if it's in position 1, 1, then we look at one below, one above, below, one below, above. So, and then we go down here, and if it is up here, like on the 4 corners, so it's either the centerpiece or the 4 corners. Yep. So let's play. Oh, I did say I was going to explain column number. So because the columns are A, B, C, then we need to get the index from that array. So I just get the index of that array and return that for the column number, because that'll give the index for the column. Let's play. Enter the number of... Oop. That's my bad. I did not... I got excited about this game. It's fun. And I did not set that. All right. That's our startup. Okay. So first thing you'll see is the blank board here. It's X's turn. So we're going to go A1. Cool. O is going to go B2. X is going to go A3. Now, the obvious place for B to go or O to go would be A2. Let's do that. A little bit longer. So now X really should go C2. But let's say you're just not quite paying attention. Let me go B1. So now we're going to go C2 and O will be the winner. Cool. So let's play one more time. A1. B1. So we're going for a draw on this one. A2. B3. A. E. And as you guys can tell, there's not possibly a winner, but that was not, predictive was not built into this. So we're going to go C2. No winner, it's a draw. One last thing, and I should have showed you this during one of those others, but if you do A1 for X, and then you try to do A1 for O, it's going to give you invalid selection. So we're going to do B1. Now let's say we're in X again, and we want to do A1. So we type that in. Still, it's an invalid selection because it's got something there. You have to pick a new one. So we're going to do C1. I'll go ahead and close this. I'm not going to finish that game. But there you guys go. Really awesome. A lot of fun putting this stuff together. That's pretty much it. I'll catch y'all next week.